Assalamu alaikum. Good morning, everyone. Thank you very much for attending this webinar series jointly organized by the College of Science and Engineering and MOTC. So the title of our webinar today is Blockchain Applications for COVID-19. The speakers will be myself, Dr. Muhammad Abdullah. I'm an associate professor at College of Science and Engineering at HBKU. And my colleague, Dr. Nuruddin Lasla, he's a research fellow at the same college at HBKU. So what will be the outline of our talk? So our talk actually, or this webinar will be split into two parts. The first part will actually try to give you an idea of what's blockchain, in case you don't know what's blockchain. And then the second part will be mainly about how blockchain application can be very useful in the area of COVID-19. And then we were going to end this webinar by a Q&A session. So if you please, you have any question, appreciate if you can type it in the Q&A tab. You can find it in the right part of your screen, and we'll answer them by the end of in this webinar. So okay, so let's start. We're going to start with the blockchain overview. I'm going to present this part. So in the beginning, what happened, like it started in 2008, where there is a huge economic crisis, which hits most of the financial markets. And one of the main reasons for this is actually the banks. So the banks, if you think about it, they are like a centralized ledger where they handle all the transactions related to our money. So in this economic crisis, there were many bad decisions taken by the banks in borrowing and lending money to people without no guarantees. And this kind of centralized ledger, the users were not they don't have an access to these kinds of decisions. So people started to lose trust in bank. So the solution for this is actually, rather than having a centralized ledger where the user cannot see what's happening inside, they cannot audit what kind of transaction, there was this idea that showed up is actually the distributed ledger. The idea of a distributed ledger, that rather than having all the transaction placed in a centralized part, the distributed ledger, that all the transaction will be shared among all the users. So any transaction between all the users will be shared among all of them. And there will be exact copies of the distributed ledger among all users. So this kind of distributed ledger will allow people to publicly audit these transactions. So it creates a kind of more transparency to the users and see how their money will be handled. However, this problem of distributed ledger, even though it's nice, but it comes with some disadvantages or some problems. One of these problems, how to update this ledger. For example, you have multiple users here, each of one have a copy of this distributed ledger. So you may end up like, for example, one untrusted party, he can join and he can change the data on this distributed ledger. And so how can this kind of problem can be solved? And the other problem is how to make sure that whenever a new transactions come, how to make sure that all the users will agree on what kind of transaction should be added on to this distributed ledger. And so you need to have a kind of consistency in how to update this ledger. So in 2008, this is actually what's the big start of blockchain. A guy called Satoshi Nakamoto, he actually introduced the Bitcoin. And I'm pretty sure all of you know what Bitcoin is, a cryptocurrency. And he solved this trust problem of distributing the ledger. And he introduced the blockchain technology, which actually it provides rules to update, how to update the distributed ledger and ensures consistency. So let's see what's blockchain exactly. So you may have like heard many terminologies about blockchain. For example, you heard about Bitcoin, you heard about the smart contracts, you heard about Ethereum, you heard about mining, proof of work, peer-to-peer. So all these kind of terminologies, okay, so what's the question? The question here, what exactly is a blockchain? So as we said, blockchain is actually the following. It's actually, first of all, it's a distributed ledger, as we mentioned before. And it has the following two main features. The first feature is tamper-proof, that any data that is stored in distributed ledger cannot be modified, or if it can be modified, it will be easily detected. The second nice feature about this distributed ledger is consensus. It means like all the users should agree. There is a technique of all the users agree on what kind of transaction should be added to this distributed ledger. So by having these two features, you will have consistency in updating this distributed ledger, and at the same time, you will develop a trust in making sure that none of this data will be altered or changed or modified. So these three parts, this is actually the blockchain. So it's a distributed ledger with these nice features. So on top of this blockchain, there have been many applications that have been developed, like Bitcoin, all the cryptocurrencies that you heard about. There have also been distributed applications where we can run like some distributed computing. There actually have been some application or peer-to-peer trading. We are going to explain most of these applications in the second part. So now we have this blockchain. So let's talk about how the blockchain is actually designed to ensure this kind of tamper-proof and ensure consistency. So, for example, if you look at the first part, which is the tamper-proof data, or we call it immutability. So how it is done, it's actually the idea of blockchain, it's actually a data structure where there's a set of blocks where they are all chained together, okay? So how this is actually, that's why it's called blockchain. So let's see how these blocks of data or transaction, they are chained together, which will provide this kind of tamper-proof data. So now assume that you received a set of transactions. You have the number of users, they are sending transaction among themselves. So this set of transactions will be collected together and they will be forming one block. So the one block will be a set of transactions. So this block, in addition to this set of transactions, will have a block ID, okay, and the nonce. A nonce is a random number, which we are going to explain later. What's the main purpose of this? It's very important, and we're going to explain later what's the definition or what's the purpose of this nonce. So what's the block ID? The block ID is actually you collect the transaction IDs and the nonce, which is the random number, and you pass them through an encryption function. It's like a security function, and you generate this block ID. Then, once you receive another set of transactions, you will form a new block, okay? And then all these blocks will be chained together. How the chaining is happening? The chaining is happening, for example, if you look at this block, now each block will not only have the nonce and the block ID, but will also have the previous block ID. So any block ID, the new block ID, will be the function, the encryption function of the transactions IDs, the nonce, and the previous block ID. So if you think about it, so at any point, the block ID will be actually include the ID of the previous block. So at a certain point, the ID will be function of all the previous block ID. This kind of chaining through the block IDs will give you the feature that any modification in this blockchain can be easily detected. So how? Let's give an example, okay? So if you look at, first of all, let's explain what's the encryption function. So the encryption function, it's a very well-known encryption function called hash function. With the hash function, the operation of the hash function is the process of converting any input or any size of data into a fixed size string. For example, if you have the transaction ID, it's 10 kilobyte, 1 megabyte, whatever the size of this input, the output will be always a fixed transaction ID, as you see on your right here. But it also has two main features. It's unique, which means that if you have different inputs, it will produce different hash values. So you cannot have, for example, two different inputs with the same hash value. So this is the unique feature. The other important feature, it is secure, which is impossible to determine the input from the hash value. So if I know the hash value, I will not be able to know what's the input. So let's see how this hash function or this structure of the blockchain will help you in detecting any change of data. So let's assume that you have this blockchain and they are all connected together like this, chained together with these block IDs. Let's assume, for example, in the second block, you have made like one of the users decided, or an attacker decided to change the transaction ID. For example, he's saying that I buy this amount or this amount of product with $10, then I change it for $5, for example. Once I change the transaction ID, then it will affect its block ID. Okay, so the block ID will change, and then this block ID will be propagated to the second block, and it will affect the new block ID because the new block ID is a function of the previous block ID, and this will be propagated over all the blockchain. So this will easily, in case of any change, it will be easily detected by the blockchain, and also I can know the source or where is the block that had where the data has been changed. So by doing this blockchaining with this block IDs, I can make sure that the data cannot be changed. The other important part of the distributed ledger is consensus, which is how to achieve agreement. So you receive a number of transactions and you want all the users to agree on the set of transactions that you should be added to every part of the distributed ledger that the copy they have. So for example, now we have a lot of transactions coming to this blockchain and you have multiple users, each one of them will receive these transactions, okay? So now I want to see how we're going to make sure that all the users will agree, okay, on what kind, how the transactions will be added or what kind of block I should add to their blockchain. So this is actually is done with a race-based election mechanism. So the main idea here is we need to start you need to select a user, okay, who will be handling which data should be added to the block, who is going to create the new block, okay? So to do this, okay, this is actually the idea of mining, if you heard about mining. So the idea here is the following, okay? So the blockchain, there will be a puzzle. Whenever we receive a new set of transaction, there will be a puzzle, okay? This puzzle, it's a block related, okay? We call it a proof of work. We are going to explain it now, okay? And then all the users will try to solve this puzzle. The winner of this puzzle, okay, the winner of this puzzle, he will be the one that will be creating the new block, and he will share it among all the users. They will verify if this block is correct, and it will be added, okay? So this is done for each block. So every time a block is added, there will be a new race. And then we reward, and actually there is some reward in the for the winner. For example, in the Bitcoin, the winner can, for example, get a Bitcoin, a part of Bitcoin, in case he win the puzzle. This idea of the puzzle solving is the mining, okay, which all of you have maybe heard about it related to Bitcoin. So if you look at the technique, how it is done, it's very simple, okay? So as we said, each computer, which we call it in this case miner, will try to solve a mathematical puzzle. This mathematical puzzle is as follows, okay? If you look at the function here on the right, so actually, now we are going to see what's the purpose of this nonce. So the nonce actually, the function here is just try to find the hash function, okay? You are trying to find the nonce, the random number, such that this nonce, but the transaction ID plus the previous block ID, the hash of these values will be less than equal to a specific target designed by the blockchain. So now every user will start searching for this nonce that will achieve this target. So it's like a brute force method. They are always trying to solve this problem. And this problem is actually this puzzle can be very competitive, very like computation intensive. You can reach, for example, you can do up to 1,000 terahertz per second, and it consumes a lot of CPU, electricity, and time consuming. So it has a huge cost. That's why the mining, as you heard about it, it's really takes a lot of energy in order to really to mine and get to do the mining process within the blockchain. So what is the purpose of this? Why they make it so hard like this? The purpose of this, to make it so hard like this, is to make hard, for example, if one attacker wants to join the blockchain and he wants to change the data, he needs to spend a lot of cost, okay, in order to change a transaction with a block. So they make it intentionally so hard so that the people, any attacker, he knows that if you want to change a block, even one block, he needs to really spend a lot of money and cost. So this is the main idea of blockchain, okay? And so that by doing this consensus and by doing this tamper proof, we can maintain a distributed ledger which is consistent and the data cannot be changed. So let's look about the blockchain timeline, how the blockchain evolved. So as we said, we started with 2008, this paper by Satoshi. And then in 2009, they started the Bitcoin, which all of us know. And then in 2013, okay, they started a new blockchain, which blockchain 2.0, which is called Ethereum smart contract. So from 2008 to 2013, actually, if you think about the Bitcoin, it was just a distributed database where people just storing their financial transaction. Started 2013, this Ethereum smart contract, okay, they actually introduced new applications for blockchain where sorry, new distributed application for example, where you can do distributed computing. So rather than only doing a financial transaction, you can actually running applications, like some codes, okay? And this provided like many applications. We're going to talk about them now, distributed application and prototypes. And then in 2019, because we're going to see like the blockchain now, because it becomes very important and it's like has been used by many users. They now looks at scalability of the blockchain, because we're going to explain later that blockchain is not easily scalable. So there have been many solutions how to make the blockchain scalable, which is blockchain 3.0. So if you look at blockchain 2.0 smart contract, that this guy in Vitalik Buterin in 2013, he developed this a self-program execution for building decentralized app on top of the blockchain. So if you look at the Ethereum, it's actually a distributed ledger, okay? And on top of this, if there is a virtual machine, okay, which can run, this is the new blockchain network, the Ethereum, which can run a smart contract. This smart contract, okay, it's actually a kind of a contract terms between the users. If you think about it, it's a piece of code that where the users agree, for example, if they want to do trading, okay, then the trading will be decided by specific contract term and business logic. This will be stored in a smart contract, which is a program, a piece of code that will be stored in the virtual machine. This actually created many applications for blockchain and make it very useful. Okay, for example, in the financial markets, in the health application, for the trading, for the supply chain management, because we allow now to run distributed app over top of the smart contract. There is also two types of blockchain, which is called public versus private blockchain. So the public blockchain is open for public participation, like for example the Bitcoin and Ethereum. Anyone which can join this blockchain, and it's publicly audited. For example, you can go and download the blockchain, the distributed ledger for the Bitcoin, and you can see what are the transactions that has been held at any time. And actually, the type of consensus algorithm used is a proof of work or proof of stake, which is a different type of consensus algorithm. And it's a nice, it has many good features, but the problem with it is a poor throughput, because you need to really spend a lot of time mining. So the number of transactions that you can handle per second is not that high. Then there was this idea of private blockchain, which we don't need everybody to join in. Like for example, for specific application, if like some users or some business, they want to do some blockchain together, then you can have a consortium blockchain. Only authorized parties can join this blockchain, and it's only closed and open for public to read. It can either be closed or open, depends on the application. And then what there are now new types of different types of consensus algorithms, like proof of authority, Byzantine fault tolerance, which is actually have less kind of competition, because now all the parties are trusted, and it has better throughput. And these types of like examples for these types of private blockchain is Hyperledger or Quorum. So now the blockchain has very makes the network safe. It has very nice application, but it does not scale well. Okay, what does I mean by scale well? For example, if you have a centralized system like the bank that we showed, if you have a huge number of transactions coming to the bank, then by adding the number of nodes or the computing nodes within the centralized node, your performance can get higher in terms of processing the transaction. However, the blockchain is not the same thing. When you add more nodes, it's good in terms of security, because add more miners, you have more people that make sure that any data will be verified. But at the other side, because of this mining process, there are a lot of communication overhead that happens between the different users or the different miners. So actually this leads to the performance of the blockchain becomes not scalable. So adding new users will have really problem in terms of scalability. So we have a constrained scalability. The transactions per second is actually low for Bitcoin, 7 transactions per second for Bitcoin, 17 transactions per second for Ethereum. We have delay. And also the most important thing is also not environment friendly. So you have a lot of carbon dioxide emission because of this proof of work problem. So this actually limits the application of blockchain on high scale, on high number of users. So now people have looked about how to address scalability, and they come up with blockchain 3.0. So the main idea of blockchain 3.0 addresses scalability, rather than having every transaction being held by the blockchain, we can actually move some of the transactions to another side chain off layer, and whenever all the transactions, and then these like two users can handle the transaction together, and then we can aggregate this transaction and, for example, send it every week. And for example, if you are going to a coffee place or any merchant and you're doing regular transaction with them, and rather than every time you do a simple transaction, you add it to the blockchain, you can, for example, at every week, okay, you can aggregate this number of transactions and you can put it in the blockchain. So this actually, but this is, you need to have, there is a trade-off on this, it's security, because you need to somehow, there is to make sure that these people who are doing the transaction, they're actually trusted. So there have been like different types of doing this scalability. There is also the state channels. This we call them state channels. Or as I said, like a number of users where they are trusted, they can do their transaction together. And usually this kind of transactions, they are cheap because they don't need to go to the blockchain. Actually, the transaction for a blockchain, it's actually, there is a money for this. And they have some open channel or closed channel. Once they have an open channel, once the channel finish all the transactions, they close it and send it to the main chain. And there are different projects now coming in Bitcoins, like Lightning Network or Radiant Network for Ethereum, that try to implement this solution. Another one, which is a side chain, if you think about it, rather than having one channel and one blockchain, you can have two blockchain. There is the main chain, and there is a side chain, like a number of users, they can actually do a smaller blockchain. And then these blockchain, they are linked together. They are linked together to transfer any state. So they sacrifice decentralization in terms of scalability, and they maintain guarantee overall security and dispute resolution. The project for this is the Plasma Proof of Authority Networks and Liquid. Then in the multi-chain, then there is another project, which is the multi-chain, which is because now we have different types of blockchain. So we have like, there is this, you need to create some blockchain interoperability. So for example, if you have a blockchain, some user in a specific blockchain, so and another user in other blockchain, so how they can connect to each other? So they can, like the users from network A could send tokens to user in network B without the need of any intermediate. The project for this is Cosmos, Polkadot, and OneChain. And then the last one is actually sharding. Sharding is actually another type of scalability. Rather than having the blockchain handle all the users, handling all the transactions, what we can do, the ledger history could be split into separate pieces, and every number of users will be multiple shards will be maintained by different number of nodes within the blockchain parallel to each other. And there will be some cross-sharded communication would be held through protocol rules. So there are projects like this, like the Rapid Chain and Ethereum 2.0. So here the main idea of this blockchain 3 is try to really, rather than having everything on the blockchain, try to create different chains and how to create interconnectivity with each other and make sure it's secure. So this is, I give you an overview of the blockchain, and I give you like an overview of the blockchain. For the second part, my colleague, Dr. Noureddin Lassa, will show you how this blockchain application can be used for the era of COVID-19. Thank you very much. Dr. Noureddin.
Assalamu alaikum. Hello, everyone. Let's now move to the second part of the presentation. So for this second part, we will see blockchain in action, and we'll mainly see some potential application of blockchain, and mainly related to the COVID-19. So during this pandemic that causes the COVID-19 disease, many factories, we have noticed that many factories and services that have shut down due to safety concerns, and that has led to having an unprecedented demand of certain goods, such as medical and other vital goods. And this huge demand had led to has forced users to source their supplies without necessarily knowing the source or the quality of their goods, and sometimes from very far away sources, which make it difficult to predict and to plan supply chain accordingly. This also have led to have like bad connectivity and communication between the different stakeholders to share data related to supply chain. So under this specific condition, blockchain can present potential solution to all of this problem. Mainly blockchain can easily and quickly build and connect all the stakeholders around a single platform to share data related to supply chain management, while being completely transparent and providing security. This is why many of the blockchain solutions that have been developed or deployed in the wake of the pandemic are mainly to improve collaborations and also data and resource sharing, doctors, but also to include other potential stakeholders. For instance, if we consider the result of the massive COVID-19 screening, this record need to be also visible to other stakeholders such as airline companies, shopping malls, government institutions. All of this in order to make appropriate decisions that ensure public safety. So in summary, we can say that blockchain can be very effective for supply chain management, mainly to improve collaboration and data sharing. Blockchain can be very efficient also for document sharing and record sharing, such as medical record and official documents such as certificate and so on. Blockchain, by providing like kind of digital cash, can also reduce contacts and help and participate in applying and respecting social distancing, which is an important measure to mitigate to the COVID-19 pandemic. So let's now see some example of important projects. So we will present like 4 main projects. The 2 last projects are 2 projects which are ongoing projects within our division in the University of Hamad bin Khalifa. So the first project is about sharing internet bandwidth between different users in a completely decentralized manner without relying to any service provider. This is like have been developed by private Singapore company in 2017. The second project is about providing like a way to share digital official documents, thanks to the blockchain technology that ensure transparency and security. This is an open source project that have been initiated by MIT Media Lab in 2017, and it is still under hot development in GitHub. The third project is about peer-to-peer energy trading. This is a project that have been developed in our division, and it consists on enabling like kind of peer-to-peer energy trading, for example, for enabling electrical vehicle charging without making major changes to the existing infrastructure. The last project, which is very related to COVID-19 and have been recently awarded by KNRF, and the idea of this project is to provide like kind of rewarding and transparent rewarding system for people to commit to confinement. We'll see more details in the next slide about this project. So the idea of the Amber project is to, in condition where there is lack of reliable internet connection, the idea is to like build like mesh networks by using specific wireless devices that will host two main functions. The first one is to host the blockchain networks, and also the second one is to route and enable like connecting different users to share their internet connections. And then by using blockchain, it will be like an open trading platform for internet connection. So this is their global architecture. We have like different users that are using these Amber wireless devices to create like mesh network between the different users. And some users like have like internet connections either by connecting to fiber optic network or satellite networks, and then user with bad connectivity or users that don't have connectivity, by using this wireless devices and also by using the trading platform, can now directly buy and sell internet connection between them. The second project is Cert, which is mainly about sharing record or official documents between different users and between different institutions. So a certificate which is provide like a proof of achievement of something, such as study or training or participation, and it is delivered by the corresponding authority. So this kind of certificate in traditionally need different steps before being able to be used. So the first step is the creation, where it needs to be printed and then signed, and need to be also protected. This process needs to be protected from any malicious users. The second step is we this document need to be protected from being destroyed. That need sometimes to be placed in very safe place, in expensive place, and also it need to be protected from malicious users. The third steps is authentications. So sometimes the document need to be authentication, especially for people that join new work in another countries. So it need to be time-stamped, and also it is time-consuming, and also it is expensive, because sometimes the holder of the document need to travel from one country to another. So the idea of BlockCert is to remove all these burden steps by using blockchain technology that enable to exchange or to share certain digital certificate between the different users. So let's take an example of the university. For example, new fresh student that have recently graduated, he can ask his university for a digital certificate. So then the university will create a digital certificate and also record this certificate in a blockchain by signing this digital certificate using its private key. So then it will provide back to the student the digital certificates as well as the ID of the transaction recorded in the blockchain. So now when the student, for example, is go to or want to join a company for work, he can just provide this digital certificate plus the transaction ID or the ID of the record in the blockchain. Now the company can just fetch the record from the blockchain and then verify, make a simple comparison between the provided digital certificate and the certificate which is recorded in the blockchain. In addition, blockchain have like a very important property, which is time-stamped, which can provide the existing of specific data at specific point in time. For example, if the user or the student have graduated in 2015, so now the company can really check that that record has been added to the blockchain at exactly that year. So the third project, which has been developed or which is have been developed in our division, and it also under the umbrella of TASMO Innovation Lab at MOTC as a promising and innovative research project. So the idea of the project is that because in the near future there will be like a huge demand on clean energy. And this demand is mainly caused by two main factors. The first one is the global commitment to reduce carbon emissions, which is known as Paris Agreement. And the second one is the proliferation of new technologies, smart technologies, for example, solar panel and electrical vehicle and electrical vehicles. So for indications that at the end of 2019, there is more than 7 million electrical vehicles sold. So this has created like a global revolution in local energy generation, where the traditional consumer can become also producer, or what we know is known as prosumers. However, for this new or for this revolution to happen, we need to open the energy market, and this is what is the purpose or the main purpose of this project. So this is the architecture, the global architecture of our system. We have like the traditional energy consumers and the traditional energy providers, but there is more new kind of producers such as private energy providers and maybe small companies that have like solar panel installed in big land. In addition to this, we have like our trading platform, blockchain-based trading platform, to handle all the transaction or mainly the buy and sell of electricity between the provider and the consumer. And we keep relying on the utility company mainly because it is handling the infrastructure and managing the infrastructure, including the grid network as well as the smart meters, and also it to handle the billing system. So we have also provided or developed two mobile applications mainly to facilitate the interaction of the users with the blockchain or with the trading platforms. So this is the prototype that we have developed. For example, at the left picture, we have like two mobile applications, one for the energy providers and one for the energy consumers. And we have the 2 smart meters that are also connected to the trading platform, the blockchain, and their main purpose is to verify and check if the physical transfer of the electricity has happened exactly as it has been agreed in logically in the trading platform. And we have at the right picture the different interaction that can happen between the different actors of the system, starting from the buyer that sent the request that he wants to charge his electrical vehicle until the end of the utility company that generate the billing by having a look to the blockchain and extract or check the balance of each of the users before deducing the billing. In addition to having looked to their smart meters. So to develop this project, we have using different kind of technologies. We have mainly used the private version of Ethereum blockchain by using proof of authority consensus algorithm. We have developed and defined the business logic or the trading logic using Solidity smart contract language. And we have also used the Docker environment mainly to build our test networks. For the mobile application, we have used Android, and we have used this this beautiful library Web3.js, which facilitate the interaction between the smart Java code and the blockchain or the Ethereum smart contract. We have also used this powerful tool, which main purpose is to write and deploy Solidity contract directly from the browser. We have also evaluated the performance of our testing platform. We have been able, mainly by measuring throughput and the latency, we have been able to reach a throughput, which means that a certain number of transactions per second, which is about 350 transactions per second, and in an average latency of about 4 seconds. So the last project, which is a very recent project that we have recently awarded by QNRF in response to the RRC call, So the idea of the project is that because until now there is, and in the waiting of the vaccine, so the viable or the most viable solution to mitigate to the pandemic is to stay at home or applying social distancing. However, what we have noticed from our experience, 3 months of experience of confinement, we have noticed that people start getting boring of this situation, and especially that the number of cases or statistics about the new cases are not really, the trend are not very clear. Sometimes it gets increasing, sometimes it gets decreasing. And also there is no clear view or vision about when this pandemic will disappear and when the vaccine will be available. So this is why the lack of an additional incentive, it may make it very difficult for people to stay committing to this confinement. And this is why we are proposing this project, that the idea of the project is to reward people to stay at home, to reward people and incentivize people to stay at home or to prolong their stay at home, and using blockchain technology to enable a kind of completely transparent system for rewarding and ranking people for their commitment. The system also need to support different kind of users profiles. For example, we have users that need to go to work and use other users that not really need to go to work. So we have different profile and different way to rank them. And we, of course, we need to keep this rewarding system as long as the pandemic is there, and by, for example, by periodically providing a reward, for example, every 14 days. Basically, the idea of the project is that each user will have like a mobile application that will continually monitor the commitment of the users to the confinement, and then send like a report to the smart contract or to the blockchain about the commitment state of each users. And then the smart contract periodically announce the winner or announce the top winners or the ranking of the different users. This kind of how to reward these people will be defined later. And of course, we have different users profile handled by the smart contract. So in summary, we will use mainly to monitor the confinement or to to monitor the state of the confinement of each user will be mainly using Wi-Fi technology, and we will define like confinement area, and then the device will continually monitor the position of the device with respect to this confinement area. And then each user also we'll have like a digital wallet, which mainly allow him to send signed transaction to the blockchain. And we continually, the smart contract continually rank the users according to their profile and confinement to confinement. So by this, we reach the conclusion of this talk. So in conclusion, we can say that we have seen that blockchain, by providing like a secure kind of decentralized and immutable distributed ledger that enable like kind of peer-to-peer exchange of value, can be very useful or very important and promising technology, mainly to remove the single point of failures and also to enable collaboration in trustless environment. We have also seen that based on these technologies and these features, this blockchain can enable different kind of application in different sectors, from healthcare, supply chain, energy, finance, research sharing, etc. And all of this mainly to enable like efficient way of collaborating between different stakeholders or business. We have also seen that blockchain can be very useful in situations, in crisis situation. We have seen that, for example, in the 2008 economic crisis, where the source of the crisis is the fact that we are relying to a single point of trust. So blockchain can be, if blockchain can have been placed at that time, that this crisis could be avoided. We have also seen in the current COVID-19 crisis, how blockchain, by enabling like an efficient way to collaborate between the different stakeholders and specifically between new stakeholders, how it can be very useful, as we have seen, for example, in the case of supply chain and also for medical or document sharing. So by this, we reach the end of this presentation. Now we will move to the Q&A session.
So we have two questions here that we received. So there have been many reports of Bitcoins being stolen. So it's possible to hack the blockchain?
Yes, actually, the report of that Bitcoin have been stolen, it's not mainly related to the technology or the vulnerability in the technology itself, but it's mainly related to this Bitcoin have been stolen from the exchangers or from storing the private key of some users. But from 2008 until now, there is now no single attack that targeted or successfully attacked the blockchain network itself.
Excellent. So this is a second question: how blockchain ledger is different from current distributed database system? That's a good question, and actually we always people does not really understand the difference. But in generally, the difference, as we highlighted, like I presented in the first 3-4 slide. So actually, it's a distributed system, but it has two main features: that the data that can be stored in this distributed system is actually tamper-proof, cannot be changed through this chaining of the blocks through this hash functions. And the second main issue, that is the consensus, that all the users needs to reach a consensus and agreement based on the consensus algorithm, how the data will be added to the blockchain. So this is how it's really, so at the end, we can make sure that whatever is added to the blockchain is actually trusted and agreed on by all the users in the blockchain. So this is actually the main difference between both of them.
If you can allow me, I can.
Yeah, sure. If you're gonna elaborate more, sure.
On this, yeah. So if you compare blockchain to distributed database or traditional distributed database, maybe one of the clear and main difference is that traditional distributed database, the management of that database is still centralized. There is only a single point of management. However, in blockchain, the management of the system is completely distributed, and it is back to the users or back to the consensus algorithm, and it is mainly handled by the consensus algorithm, and there is no single point of failure. So this is the main difference between the traditional distributed database and the current blockchain. And also comparing the blockchain with traditional distributed system. Actually, distributed system is it is very old field of research in computer science, and even the consensus algorithm have been tackled in more than decades from now. But the main difference, or what blockchain or the idea of Satoshi Nakamoto is that he has enabled to reach consensus in a public distributed system. Traditional distributed system were closed. All the entities, we know the entities of the systems, and we have very hard, sometimes very hard assumption. But what Bitcoin and blockchain, it come in completely open system, such as the case of Bitcoin or Ethereum, where any users can join and leave the network. They can reach consensus while being completely secure and transparent. And this is one of the key innovation and which make this technology really attractive and promising technology.
Thank you very much. That's a very nice reply. Okay, so these are the two questions that we received. So by the end, I would like to thank you, everyone for attending this very nice presentation. So thank you very much for attending. So we'll send you a link for the recorded sessions. If any of you have any questions, please email us at this is my email. And also you can find our profiles at HBQ. So stay at home and stay safe. And thank you very much for attending this webinar. Thank you.